Let's see. This is the utility function, not the standard one. That's not CS because of these two. Be careful. This utility function does not have a shortcut because of that too. If this 2 wasn't there, that was CS, but this is not CS. This is not a standard function. The income is 100,000. The price of Y is always 1. In part A, the price of X is 1, but there's rationing. The maximum X you can consume is 5,000. To solve it, you ignore this one, see what the individual wants to do. If you want to consume more, he cannot, you will be rationed. Otherwise, you just leave it as this. Alright? Okay, so we're going to do that here. We're going to find the optimal bundle, and for that we need MRS. What's the MRS there? You need to take derivatives and find it. What is MUX? That is MUX. I took a derivative, right? What is MUI? That is MUI. So if you solve it a bit, the MRS should look like this. That is the MRS. And in equilibrium, it's equal to relative price, which for the timing is 1. And then you solve for Y. And then you get Y from it, which should be 16x because that 2 goes to the power of 4, and that is 16. Right? Yes. Then you have to use a bottom line to solve for the optimum bundle. Take this one there. That will give you 17x equal to 100,000. So what would be x? What do you get there? What is 100,000 divided by 17? Anyone? 5? Is that possible? Oh, you're rationed. You cross it out. You're right. The maximum you can buy, that's your demand. So this individual is in a corner solution. You want to consume and part of the bottom line that's cut, not possible. Right? So I found demand for X, which is 5,000. So we call this corner solution. Here's a tangency. This is tangency. This tangency, but tangency is not possible because of rationing. Then it shows the second best, which is the ration number. Right? Now, how do you find Y then? Don't use this one anymore. That's a tendency. It doesn't hold anymore. You should use the budget line. So don't use that one. That will give a wrong number. That's a tangency condition. In a corner solution, tangency does not hold. So you should use the bottom line to get Y. That would be 95,000. Is it? Yes. So now we can get utility of rationing, which should be, let me put the numbers in the utility function. That's the utility function, which is 5,000 to the power of 75 plus 2, 95,000 to the power of 0.75. What would be that? How much do you get? What's the utility of rationing? Which is that number. What do you got? rather large number. How much do you get? $11,000, $12,000, $14,000, $11,000, 416. No, just round it. It's fine. 417. So when you go in 10,000, then rounding is not an issue. When you go like 1, 2, then rounding is a big deal. That's that one. In part B, there's no rationing, but the price of what X is 2. So we're going to do the same thing, but with the new price. The MRS was this one. That should be equal to 2. Then we're going to solve it. Four to the power of 40 is 256, I guess, right? That's that. And then we can use the budget line. Take this one there. That is 258x. That means 100,000. So what's the demand for X? What's the 100,000 divided by 258? Should be a small number. Less than 400. 300? 100,000 divided by, just round it. 80. Yeah. What is demand for Y? Now you can use both. You can put it there or there. The tendency holds. You can put it in both. You'll get the same number. So you can put it there or put it there. You will get the same number. You can always use the bottom line, but in the corner solution, don't use the tendency condition. Does not hold. Minus sort of what we had. But here, tendency holds. No corner solution. You can use both. What would be Y? What is 256 multiplied by 388? 99. 328. So now when I get the utility of no rationing, which is 388.75 plus 2 times 99328.75. What do you get? That's the satisfaction you get from no rationing. How much is it? How much? 278. This is better. The rationing is better. Right? The rationing is better. So now I have to graph it, but the rationing is better. I'm going to graph it. Pay attention, because most people who actually got the numbers right, they couldn't graph it. When I say they couldn't graph it, they graph it not perfectly correct. Something wrong with the graph. I'm going to graph it, see how it looks. That's the bottom line for part A, ignoring the ration. That's part A bottom line, but ignore the ration. The ration cuts it at 5,000. So I should cross this out. I just graphed it to get the slope right. You cross it out. That's not part of the bottom line. That is the bottom line for part A. I crossed out the part that's not possible. Anything more than 5,000 is not possible to cross out. And part B bottom line is this one. That is part B bottom line. So the individual in part A got this as a solution. He was in the corner solution. Right? For part A, for part B, he got somewhere there. In 1,000, that is 0.388, and that was 99 and change. Right? That is a no ration case. Make sense? So now I have to graph the indifference curve. If If you graph the indifference curve, pay attention to this. First, indifference curve shouldn't cross. No crossing. Don't cross the indifference curves. If they cross, you'll get deduction right away. Make sense? No crossing of the indifference curves. So when you graph the indifference curve for rationing and non-rationing, they shouldn't cross. That violates sensitivity and non-salvation. 2. More to the right. More to the right, less to the left. On the indifference curves. Make sense? That's 2. What about 3? Corner solution is not tangency. Don't graph it as tangent. That's the meaning of corner solution. You don't have MRS equal to that price, not a tangency. Make sense? Okay. So I'm going to use these 3 to graph it. That is rationing KC. It cut the bottom line. No tangency. Cut the bottom line. No tendency. That's the corner solution. Make sense? This is A. I graphed it. See, graph it flattish so they don't appear crossing. A was a tendency. No corner solutions. I have a hard time graphing it. Let me make it bigger. That's fine. The indifference curve don't cross, don't appear crossing. That's A. Rationing was better, to the right. That's B. And corner solution is not tendency. Right? That have all the 3 elements. If you would have graphed it this way, that's wrong, that crosses. Don't make it too tight. You will be crossing. Make it flatter, don't appear crossing. Make sense? So is it correct? Graph. If you would have graphed it this way, that would have been wrong too. That's a tendency. Not a corner solution anymore. That would be wrong. So you have all the 3 elements. No crossing of the indifference curve. They don't appear crossing. More to the right, the rationing was better, is all the way to the right. And corner solution is not a tendency. Alright? It cut the bottom line. Right? The tendency was there. Where is the tendency? That's a tendency. It's just not possible. You have the tendency there. That wasn't possible. It was on the part of the bottom line, not accessible. Make sense? So I didn't even graph it. I graphed the corner solution. Does that make sense? Okay, that is the correct graph. So make sure you know what's going on. It's not random lines. It follows the rules, which is more to the right, less to the left. The indifference curves don't cross. And corner solution is not a tendency. Right? Make sense? Okay, anyway. Okay, let's move on. Hopefully it made sense. Historically, people have a hard time with graphing for some reason. Number 4 is what we call quasi-linear. It's linear in y, not x. And we know already quasi-linear may give us corner solution. Anything that can give us corner solution will give us kink demand. That's the intention of this question. Run you through it all the way to the end. All right. First, it says set up Lagrangian. That's a Lagrangian. That is what you try to maximize. That is the Lagrangian parameter to implement the constraint. That's your Lagrangian. Alright? Then it says find FOC. If you want to optimize, you need 2 derivatives. One, that's FOC. Second, we normally don't do the second, but the second tells us whether we're maximizing or minimizing. We already know it. So we don't really do the second derivative. We stick with the first one, which is called FOC, first order condition, the first derivative. So in this case, we have to derive for x, then y, then lambda. That's x. That's y. And that is lambda. Lambda ensures the polygon is applied. So now I have three equations, three variables. Which one we don't need? The one we don't need is lambda is not useless. Lambda actually has a meaning. That's called shadow price, right? Has a lot of meanings, but we don't care about it here, right? All the courses has a meaning. They found it, they applied, but we don't care about it here. So we don't care about it here. We want to eliminate it, and the easiest way to eliminate it is take the first two, rearrange them, and divide them. That will cancel out the one that we don't want, which is the lambda. You will end up with this. That is your MRS equal to relative price. Right? If you arrange the MRS, it should look like this. That's your MRS. Make sense? Okay. Then it says, use the MRS to graph an indifference curve. Indifference map. That's the slope of the indifference curve, ignoring the sign. How does it look like? That should tell you how the indifference curve looks like. That's the slope of it, right? How does it look like? Anyone? Based on the slope given there, how does the indifference curve look like? Anyone? Well, if x goes to 0, that is how much? Infinite. If x goes to infinite, that's how much? 0. That's the definition of convex in the origin. One side is 0, one side is infinite, right? So what's the difference between this one and, say, MRS of Cobb, Douglas, or CS? They're all convex to the origin. What's the difference then? The MRS of Cobb, Douglas gave you convex to the origin too. Make sense? So what's the difference between that and this one? The only difference is, in the MRS there is no y. So you get convex smooth to the origin, regardless of what y is. Make sense? Y can be anything. I.e., the indifference curve can map into the fourth quadrant because there's no limit on y. If you take Cobb-Douglas, say Cobb-Douglas, the MRS is this one. You want this to be more than 0, that limits y to the first quadrant. That forces you to be on the first quadrant. But here there's nothing. There's no y. Y can be anything. You can actually venture into fourth quadrant. You get a convex smooth to the origin, indifference map, but you will venture into a wrong quadrant. Make sense? That's sort of what it is. That will come to play later when we actually find upland zone. So let's solve it. I'm going to solve for MRS equal to relative price. I'm going to take this one. Put it equal to relative price and solve for x. What do you get? You will get this one. That's what you get, right? Now this is what you want to buy. Let's call that star. This is what you want to buy. You like to buy this. Whether your demand is this or not, it will depend whether you can afford it or not. That is what you want to buy. It will be your demand as well. If you have enough money to buy it. You want to buy, that's your demand. If you don't have enough money to buy it, then what do you do? That is, you want to buy, say, 2 units that cost you more than what you have. Then what do you buy? You buy whatever X you can afford. That's a corner solution. This is a corner solution. So whether you're in a corner solution or not depends on whether the tangency is in a wrong area or not. Is it in the first quadrant or a fourth one? If it's in the fourth one, you're in a corner solution. In the first one, you're not in a corner solution. Make sense? So that's the demand for X. What's the demand for Y? Down here, you're in a corner solution, you buy no Y. That's the corner solution. You spend all the money on X, nothing but the Y. Okay? What about up here? This is your money. This is how much you spend buying X. That's the left out. It's all what you spent on. Alright, so in the upper end, you have enough money, you buy X, whatever you want to buy. That is how much you spend on it. This is how much you spend buying X. This is how much money you have. The left out will be spent on Y. Make sense? Yes or no? Yes? Yes. Okay. So we're going to put numbers on it. That makes it better even. That is part B, which we put numbers on stuff. So we'll see how it goes. Julie had $2. Not very rich. The price of Y is 4, price of X is 1. So how much X she wants to buy? That was what she wants to buy. She wants to buy X star, which was this number. How much is it? Put the numbers there and give me the outcome. This is how much she wants to buy. How much is it? I'm basically plugging the numbers there. I want to see how much she wants to buy. How much is that one? 2 pounds? Can she afford it? X is $1. That's the price of it. That is how much she wants to buy. Can she afford it? No, that's more than the money she has. She is there in a corner solution. She doesn't have money to buy what she wants to buy, so she buys whatever she can afford. Right? She's in a corner solution. So for her, demand for X becomes, she has $2, the price of X is 1, she's going to buy 2 units of X, and she's going to buy no Y. She was in a corner solution, she did not have enough money to buy, but she would have liked to buy. Make sense? Okay? Okay. Just for the sake of it, someone else has $4. Not Julie, Julie's friend, right? What would Julie's friend do? Suppose her utility is the same. Suppose Julie's friend has exactly the same utility. They're twins, right? She's not friend, they're basic sisters, right? She has exactly the same utility. The demand is the same for her, right? She just wants to buy the same unit. Can she afford it now? She can. This, she can afford it. Demand for X is 2.52. So this has $4. She spent this amount on X. That is how much Y she will demand. Make sense? That's how much money she left with. That's the price of Y. That is how much Y she will demand. How much is that one? This is Julie's friend or twin. She's not in the corner solution because she has enough money to buy whatever she wants to buy. Make sense? How much you get there? What is 4 minus 2.52 divided by 4?
0.37.
0.37. graph both of them. Let's graph both of them. I'm going to graph the bottom line for Julie. That is 2 divided by 4. That is 2 divided by 1. That's the bottom line for Julie, right? She had a tangency in the wrong area because she ended up wanting to buy 252. She couldn't buy it. She ended up with corner solution. So there was a tangency, just in the wrong area of the budget line. That wasn't possible. I crossed it out. And I chose this as the optimal bottom. That was Judy. Make sense? Alright, so there was a tangency, just the wrong part of the budget line. Alright? This is her friend. That's her friend. She has $4. This is 4 divided by 4. This is 4. Friends of Julie wanted to buy 2.52 and she had it. She was fine. That is her friend. This is Julie. This is friends. She wanted to buy 2.52 and she had enough money, she bought it, and the rest of the money was spent on Y. So friend of Julie was not in the corner solution. Make sense? She had a tangency on the right part of the bottom line. Make sense? So whether you're in the corner solution or not, depends on how much money you have. The one we solved for, that was the bottom line. That's the bottom line. That's the Julie's bottom line, and she was on the wrong part of it. She ended up with corner solution. This one is Julie's friend. Corner solution did not exist for. Yeah.
So when we graph it in the exam, do we have to, for the corner solution, do we have to graph both?
Yes. If the way the question was, we didn't talk about Julie's friend in the question, so that was the graph. See, I had it. That's the graph.
Oh, so you have to graph both of those. Like
You have to graph what she wants to do, tendency, and what she ends up doing. Corner solution.
Okay.
Okay. Nice question. Had 15 marks. 15 marks. Not very hard to do. If you know what's going on there, it's actually not very hard to do. If you try to memorize it, like what is going on there. But it's very nice setup to it, right? And it's nice because it's not automatic. You have to know what you're doing. It's not like Cobb Douglas where you put the numbers, get the outcome. Right? The last one is last lecture, which is expected utility and insurance, stuff like that. And here I use power function. Where the power is less than 1, that makes the individual risk averse, so that is the utility. She had 400 or 1,000. What satisfaction she get from 400? That looks like 40. Is it? Yes, 20 to 40. What satisfaction she get from 1,000? I need that number, I don't remember it. What is 2 multiplied by square root of 1,000? 2 multiplied by square root of 1,000. What do you get? And 60 and how much? See, it says 2 digits. It says it there. Nominate the expected income, which is 60% of 400 plus 40% of 1,000. I know that one, that's 640. We need the expected utility, which is 60% of 40 plus 40% of 63.25. I don't remember that one. How much is that? I know the 49 side of it, but I don't know the rest. What was that? 49 point? That's the expected utility. 49 point? I know the 49. I remember that. 49 point? Three. Now we need the utility of expected income, i.e. utility of 640. That is 2 multiplied by 640 to the power of half. This should be more than 49 because the individual is risk averse. He prefers certainty over uncertainty. That's utility of expected must be higher than expected utility. What do you get there? What is 2 multiplied by square root of 64? 640. Should be more than 50. How much? 50.6. So we get that one. Now we need the certainty equivalent. So let's take the expected utility and invert it to get the certainty equivalent. So in this case, to get the certainty equivalent, I should divide the expected utility by 2 and then square it. What do you get? This should be less than 640 because that is a risk-averse individual. What's the certainty equivalent? Should be less than 640. What do you get? 607. Four. Now we have all the elements to graph it. So let's graph the whole thing and then go to the next part. That is gamble connected. That is expected utility, expected income. That's a straight line up. I think I went too far ahead. I should be somewhere there. That is 640. This is utility of expected, which is 50.6. This is expected utility, which is 49.3. And this is, what was that one? This is, give it a name. Certainty equivalent, which was 607.62. And I fill out the graph, right? Make sense? If you want to go further, what was the name of this distance? That was the Marcos premium. So the Marcos premium was 640 minus 607.62. How much is that? 32.38. Am I right? Yes. This is how much the gamble is worth to you. Alright? This is how much 400, 1,000 is worth. That's the negotiation equivalent. If someone offers you this, you're willing to pay this. Look at it that way. If someone offers you a certain income for something that's worth certain equivalent, you're willing to pay the difference. Look at it that way. But that premium is not for full insurance because if you buy full insurance, you're going to get 1,000. So we call this full insurance premium. Alright? So don't mix up these two. That's the full insurance premium. which is next question. What is the maximum willing to pay for full insurance? That's the risk premium, but full insurance, not Markowitz. That's 1,000 minus 607 pound. Was it 32? 62? That should be 9. Sorry, that should be 300. How much? 92 pound? 38? So that is the first part of this question. The second part, you're offered 50% coverage for 250. Would you do it? For the partial insurance, we use the expected utility approach. So you have the expected utility of no insurance. How much was that? 49 pound? 3? Was it 3? Find the expected utility if you buy that partial insurance, the higher the better. And for that, you need the money you end up with if you buy the insurance. So let's see what happened there. This is your own money. That's the probability of it. If you buy 50% coverage, obviously here you get nothing. What do you get if you lose? If you end up with 400, how much do you get from the insurance company? If there is a 50% coverage. This is what you get. This is your loss. You get 50% of it covered. So you're gonna get a check equal to how much? 300 bucks. That's the coverage. So 50% coverage there means 300 bucks from the insurance company. Because the coverage covers the loss, not what you end up with, not what you have. Right? But in either case, you have to pay 250. So you're gonna end up with 750 there and 450 there. You just have to calculate the expected satisfaction of that income. Right? It should be 60% of 2 multiplied by 450 to the power of 1/2 plus 40% of 2 multiplied by 750 to the power of 1/2. I need both of these two numbers in addition to the whole thing. What are these two numbers? We need them for the next part of this question. What is the utility of 450? What is that part? 2 to the 2 multiplied by the square root of 450. What do you get there? How much? 2 multiplied by the square root of 450. I'll get 2.
Yeah, 2 times the square root of 450.
Yeah.
I got 42.
42.
Yeah.
42. I thought 2.
No, 42.
42 points?
43.
42. That's right. What's the next one? What's that one? That should be in the 50s, I guess. Is it? Or not? I don't recall it. 54 points? 77. What's the whole thing then? What's the whole thing? What's the weighted average of these two? I remember that 4, 7, was it 7? I don't recall the rest. 47 pound? 37?
Yeah.
37. Okay, that is worse off. You're not gonna buy that insurance. That's not a good insurance. Not enough coverage, or you can say too high a premium. Right? Either way, you're not gonna do it. Question for you: if this probability goes up, is it more likely for you to accept that policy or less? if the probability of losing goes up, would it make it better to buy the insurance or worse? Of course better, right? If it goes up, at some point you may be indifferent between the two. The next part says find it. Find the probability of loss that makes you indifferent between buying that partial insurance and not buying it. I know it's more than 60%. It will be more than 60%. Based on the numbers you see here, do you expect it to be way higher or just slightly higher? We know it's more than 60%. I want to see if you can form expectation. Do you expect it to be way higher than 60%, say 70, 80, or just slightly higher? Which one? Why slightly higher? I've done it, so I know the number. But when I looked at it first, I said that's 47, that's 49. That's way different. In percentage change, they're way different. So I think it would be way higher, not slightly higher. If you're talking about 47, 49, that's like way different. We're not talking about 1,002 versus 1,004. 2 points here makes a big difference. That's 5% difference, right? So I expect it to be much higher, not like 1 or 2% higher. We'll see. I saw that I get it way higher, but form expectation before you actually solve it. It's higher than 60%. It will be probably much higher. Let's see. Without, that's the probability of loss. That is what you end up getting in satisfaction. We already have this one equal to 40. That's the probability of no loss. That's what you end up with in satisfaction. We already have this one. How much was it? 63? How much was that? 63 points? 2.5? That is without. With, that's the probability of loss. We ended up with this one. And I wrote the utility there. How much was that one? 40? 2 points? I wrote it. 4.3? 1 minus P. That's the utility, and this was 54.77. So to be indifferent, these two have to be the same, and then we can find the probability by rearranging. I put the probability on one side, 1 minus P to the other side. I can see the difference between these two. That's 2.43. What's the difference between 63.25, 54.77? How much is that one? 8 and change. How much is it? 53.25 minus 54.77. What do you get? What is this? Minus this. 8.4? 8. So the probability should be 8.48, 2.43 plus 8.48, which is how much? I know it's more than 6%, probably not marginally. What do you get? 77? That's the probability that makes you indifferent between buying the 50% coverage. Right? Okay. So I dragged it, stopped, talked about it. That took 2 hours. You should be able to do it in far less if you know it. If you don't know it, it may take 10 hours. You still can't do it. So it's solve it, graph it, explain it. You're not going to run out of time if you know it. If you don't know it, you cannot make it up. So the time is never an issue. The issue is whether you know it or not. So practice it. Don't assume you're going to figure it out there. You're not going to figure it out.
Does it matter if the P and 1 minus P is
No, don't switch. P is probability of loss, 1 minus P. Define it first. If you want to switch it, define it first. But the better way is to stop from directly. Otherwise, at the end, you have to stop it from on. Just a question for you. What is the average of this class in the summer? We have 200 students. It's a big group. What do you think the average was on it? 70? 60? We made it 70. Last fall was far better. The summer group is different because you get some people who are actually trying to do. There are two groups. People trying to go ahead, people left behind. The two groups, you get weird results. But last fall was better. There's nothing surprising there. Practice it. Nothing surprising there if you don't do it because you haven't practiced enough.